1, given a complex number c equals 1 plus I divided by 1 minus I, we're going to find the minimum value of a positive integer n such that c to the power of n equals 1. Okay, so basically what we want to first do is simplify our z. So remember, square root of -1 equals I. So this is a radical, right? We can take our z and take 1 plus I divided by 1 minus I and multiply it by the complex conjugate to simplify. So that would be 1 plus I, and we're going to multiply the numerator also by 1 plus I. And when you have a minus bi times a plus bi, that equals a squared plus b squared. So this is just going to equal 1 plus 1 is 2. So we're going to have 2 here. All right, now for the numerator, this is going to be a squared plus 2ab plus b squared. So that's going to be 1 plus 2i plus I squared, which is minus 1. Now, simplifying this gives me 2I divided by 2, which equals I. Now, since we have I, when we write it in this form, this is just going to equal cosine. And when you just have the I, that means we're going to use pi divided by 2. Cosine of pi divided by 2 is just 0, plus sine of pi divided by 2 times I. Let's put the I there. And again, if you just look at this, this will give you 0 plus 1 times I, which equals I. All right, so there's our trigonomic form of this. Now we need to look at c to the power of n. So when you do that, again, our r is just going to be 1. So basically, when you do your r, that's just going to be the square root of 0 squared plus 1 squared. So that's just r, and r is 1. And 1 to the nth power is just 1. So we don't need to do anything with that. And then we're going to have cosine of pi divided by 2 plus I times sine of pi divided by 2 to the power of n. And this is using this formula here. This is just a shortcut for writing what we just wrote. Okay, now let's go ahead and finish this off. This is going to be c to the power of n equals cosine of n times pi divided by 2 plus I times sine of n pi divided by 2. All right, now looking at that, this is going to equal 1 because it's given that this equals 1. That means this is 1 plus 0i. That means we have cosine of n times pi divided by 2 equals 1, but I, we don't need to put the I because the i's will cancel out, our sine of n times pi divided by 2 equals 0. So I'm going to write that down again because we're running out of room. So we have cosine of n times pi divided by 2 equals 1. And then we have sine of n times pi divided by 2 equals 0. All right, now again, we're trying to find the minimum value of the positive integer n. So basically, if we just look for this one, for cosine, we get n pi divided by 2 equals 2 pi, right? Because we want cosine of this theta to equal 1, it's going to be pi times k. All right? So therefore, this is for some k that's an integer, and it's a positive integer. All right. If you solve for this, the pi's cancel, and you cross multiply, you're going to get n equals 4k. Now, if we're looking at integers, we're starting at 1, 2, 3, like that. The minimum is 1. So when we have k equals 1, we're going to get n equals 4 times 1, which equals 4. So our minimum value is at n equals 4. And that's it. Thank you. Have a nice day. Bye-bye.